All right, welcome back. This is part 2 for veterinary physiology and anatomy, the reproductive system. Oh, I don't want that. I want that. I think I want that. Okay. Okay. So now we turn our attention to the female, and we're going to look at the same sort of things, the physiology and the structures and all that. Hold on. So this is showing you, actually, this is a human uterus. You'll see that dog uteruses, the cow uterus, the horse uterus, they all look a little different. But what we got here, this is the cervix here. So down below the screen would be the vagina leading to the cervix. This is the body of the uterus. And then we have the right horn and the left horn. And then this is one ovary here. I'm sorry, one ovary here and one ovary there. And again, uterine horns, uterine body, cervix, leading to the vagina and then the vulva. And so let's watch what's actually happening here. In this video, you're going to watch a follicle develop on the ovary. The follicle is going to burst open. That's ovulation. It will burst and allow an ova to come out. And you'll see this thing that looks kind of like a weird catcher's mitt is going to catch the ovum. I should say ovum. That's the singular for ova. This catcher's mitt is called the infundibulum, another cool word to say, infundibulum. There we go, infundibulum. And then you'll see the ova will be swept down the oviduct to the uterine horn, and at the same time you'll see sperm traveling up the cervix and the uterus. So let's just watch what's happening here. So here we are at the ovary, and a little follicle is going to develop, I think. Oh, there it is, and it just ovulated. There's the ovum, or egg, if you prefer. The infundibulum catches it, and then it gets swept down the oviduct into the horn. There it is, right? But now look who else is coming, right? Here come the sperm. Some are not very bright and are trapped down here. Again, remember, they've got that nice semen with fructose and alkaline fluid to help them survive. And then they are going to, one sperm is going to get there first. Hey! And he is the proud papa of with this proud mama. Anyway, so that is now the fertilized egg, also known as a zygote, and then it can now travel down to the uterus where it will implant. And that's what we'll talk about in a few weeks. So the uterus is amazing. There is nothing quite like the uterus. Think of everything it does. It changes in size from this big to this big. It has to form a placenta so that the mother's oxygen and nutrients can be shared with the fetus without mixing with the fetus's blood. It has to remain quiet during pregnancy, and then it has to contract to deliver a newborn and expel the placenta, and then it has to return to its original size. That's crazy. There are some structures you'll be learning in the anatomy class, probably like the broad ligament and the oviduct and the ovary itself. The broad ligament is like a hammock. The uterine horns and the uterine body, they are suspended against the body wall by these sheets called the broad ligaments. And that way, if you're a female and you're running and jumping, your uterus is not flying all over the place. Instead, it kind of sits in this hammock. The uterus is also known as the womb. It has thick layers of smooth muscle that that aid in the process of parturition of this baby elephant, for example. As we said, it forms part of the placenta, which we'll learn about later. And then as the offspring develops, the placenta forms around it and attaches to the lining of the uterus so that nutrients and waste and oxygen and carbon dioxide can be exchanged. And when we do a spay, the book talks a little bit about an ovariohysterectomy. That would be a spay. These are the parts that the veterinarian is removing. We place a clamp here across the ovarian pedicle. We have to break this suspensory ligament here so that we can free the ovary from the body wall. So we place a clamp here. We have to then cut the suspensory ligament. Then we place another clamp down here in the uterine body, and then we tie that off too, and then we can remove all of this as part of an ovariohysterectomy. And again, it's kind of a similar, you can see some of the same structures over here. But when you read the clinical application about a spay, that's what it's referring to. Now let's look at some of the parts a little more closely. The ovaries are kind of like, well, the male has testicles, the female has ovaries, and together we call these the gonads. These are the names given to these special, they're glands, but they also make, they make gametes. So they're kind of cool, these things we call gonads. So first, they produce eggs. It's what did I write here? The process by which ova are produced. Oh, okay, that's just the definition of oogenesis. Now, in males, it's just unlimited how many sperm the male can make. It's a continuous process. In the female, it's different. When the female is finally born, there's a finite number of oocytes, only tens of thousands of these immature ova. And of those tens of thousands, only a few, are going to actually develop into mature ova. I say a few, I should say a small percentage of. So we want to talk about what's going to actually happen in the ovary itself. So there's this hormone, it's called estrogen, that is produced, and it's actually produced by the follicle. So the follicle, you'll see, is this little structure that develops in the ovary. That's where the estrogen, that's the part of the ovary that makes estrogen. And estrogen is kind of the female equivalent of testosterone, or you could say that testosterone is the male equivalent of estrogen. It's responsible for the physical and behavioral changes that we associate with being female, but it also will prepare the animal for breeding and pregnancy. So this just shows you an ovary, and here's this little little egg inside of a follicle. And then the follicle gets a little bigger, and the follicle gets a little bigger, and it's making estrogen. And then the follicle breaks open, what we call ovulation. The egg is ejected, and now that follicle turns into a brand new structure. It kind of collapses on itself and becomes a new structure called the corpus luteum. And we'll talk more about that in a moment. The corpus luteum, it is going to make a hormone that will help prepare the uterus for implantation of the fertilized ovum and for maintaining pregnancy. And we'll talk more about that in a moment. So the ovarian cycle, this is, I think later I referred to the estrous cycle as being the same, and that's a mistake. The ovarian cycle is related to the estrous cycle, but let's just treat the ovarian cycle separately. It's just referring to all the things that occur as part of the process to produce this egg. So it refers to the series of changes during which the follicle matures, and then the ovum or ova burst out of the follicle, and then the corpus luteum develops. So this cycle is influenced by two hormones we learned about last week. These come from the anterior pituitary, and they're called follicle stimulating hormone and luteinizing hormone. And again, as we look at these next few slides, these are the terms you're going to want to know: follicle, ovum, ovulation, FSH, LH, and corpus luteum. And we're going to come back to this little picture here in a moment. So we're looking at an ovary here, and I added these red arrows just to kind of show you that you're following these little follicles, you're following them, or just one of them, as it develops into a larger and larger dominant or major or Graafian follicle, and then it ovulates. So in step one, so this is step one, we'll cover first. There's thousands of these little immature ova and these little individual follicles, and FSH from the anterior pituitary gland is going to stimulate the ovary, but just one or two, or I should say one or more of these follicles will begin to grow. And when it's reached maximum size, the follicle looks kind of like a blister, and this follicle is making estrogen, and at this point it's making large amounts of estrogen. So this is right about here. This is step one. You don't need to know what a Graafian follicle is. It's just, think of it as the main follicle. In step two, the anterior pituitary gland releases this surge of luteinizing hormone, and that's the signal for the follicle to spit out its egg. I'm a follicle, and I just spit out this egg. I don't know. You see that? Anyway, it's actually a Christmas ornament, but pretend it's an egg. It's explosive, and now that ova or ovum, there could be more than one, depending on the species, it gets caught by the infundibulum and ends up traveling down the oviduct. And then that empty follicle turns into a new structure called the corpus luteum. Corpus luteum means yellow body, and it makes the hormone progesterone. Now, if that ovum becomes fertilized, the now fertilized ovum sends a signal to the ovary to maintain that corpus luteum. Don't let the corpus luteum go away, because the corpus luteum will then continue to make progesterone, and progesterone supports the pregnancy. In fact, that's what progesterone means, favors gestation. And so a woman is pregnant for 9 months. The corpus luteum is why. The corpus luteum made progesterone all 9 months. And no corpus luteum, no pregnancy. The signal, this is just a side note, you don't need to know this, but I said the fertilized ova sends a signal to the ovary telling it not to, don't let anything happen to the corpus luteum. That signal is called chorionic gonadotropin, and in humans, it would be called human chorionic gonadotropin, and that's what a pregnancy test is testing for. If you go to the Dollar Tree or the drugstore, look at the pregnancy tests, and you'll see HCG. That's chorionic gonadotropin. So anyway, okay. What if the egg does not get fertilized? If it does not get fertilized, then it never sends that signal, that human chorionic gonadotropin signal. It never sends it, and then the corpus luteum goes away. It actually it just degenerates, basically. What happens is the uterus will release a prostaglandin called prostaglandin F2 alpha. And then that causes the corpus luteum to disintegrate. And then that will end this, I said estrous cycle. I guess we could use estrous cycle and ovarian cycle kind of interchangeably. But that will end the cycle, and then it can begin again with a new follicle developing, a new egg ovulating. But the time, what happens will depend on the species. Some species only do this a few times a year, and then the rest of the year, nothing's happening. But we'll talk about that a little later. So now let's discuss that again, actually looking at the actual follicle. So here we're looking at an ovary, and there's this little blister is actually a follicle there. And you're just going to see it's starting to swell. It's getting bigger and bigger, right? So follicle stimulating hormone is recruiting this particular follicle to grow bigger and bigger. And as it grows, this particular follicle is secreting more and more estrogen. The estrogen is actually, hold on, there we go, sorry. The estrogen is stimulating the anterior pituitary gland to make more FSH and LH. The estrogen is also stimulating the hypothalamus to make a hormone called gonadotropin releasing hormone. And that hormone is stimulating the anterior pituitary gland to make more FSH and LH. So you see what's happening here. We're getting a positive feedback loop. This is the opposite of a negative feedback loop. Now, FSH and LH will cause the follicle, well, FSH will make the follicle get bigger. That means more estrogen. That means more FSH. It just escalates. The goal is we're trying to get that follicle to the point that it ovulates. And then we suddenly get this spike in LH, and that's what will make the follicle finally ovulate. GnRH is one of those hormones that's made by the hypothalamus. It's not, you don't really need to know that. It's good that we talk about it today. There won't be any test questions on it, but it's just helpful. Just when you see the word gonadotropin releasing hormone, you should just be able to know what that means. Tropin, you remember, means to stimulate something. Gonadotropin releasing hormones means that it's a hormone that's going to stimulate the anterior pituitary to release its gonadotropins, right? Hormones that will stimulate the gonads. I realized that was kind of a tongue twister and probably didn't make as much sense as I thought it did, but I think you get the general idea, right? The gonadotropins would be FSH and LH, and gonadotropin releasing hormone is, well, never mind. I think you get it. And again, that surge of luteinizing hormone is what will signal this guy to ovulate. And then let's watch that. Very exciting, right? Right, LH surge, and now that empty follicle turns into the yellow body, which will produce progesterone. Now, remember we said a client may bring their cat to you, their cat to you, and the cat is meowing all night, and it's got its back up in the air, and the owner may think that he's injured his back. Well, cats and some other animals, but in particular cats, are called induced ovulators. Now, what that means is they will not ovulate until they've been bred. And by ovulate, I mean that surge of LH does not take place by itself. It takes place after they're bred. It will not take place unless they're bred. And so that cat is stuck in step one. She cannot ovulate until she has sex. Now, that's an oversimplification. There's probably something happens, but generally speaking, these cats will meow for days at a time because they're stuck in this step one. And this is part of why the tomcat's penis will have these little barbs on it. That it's kind of rough, and it will, when he breeds with the female cat, something about these little barbs will help to stimulate that surge of luteinizing hormone. And then she can finally ovulate and then have 9 little kittens that you have to take care of 70 or so days later, 65 days later. Okay. In the video this week, there was a video of a AI technician working with a stallion and a mare. And we're actually going to watch that together. But I thought you might think it was interesting to know what all this looks like on an ultrasound, because this might be you. You might find yourself working as an AI technician using your veterinary technician skills. So in that video, one of the technicians is seen ultrasounding the mare. They don't really show you what she's looking at, so I wanted to give you some examples. So this is what you might see on an ultrasound. And again, an ultrasound is it's kind of like a flashlight. It's sending sound waves into various structures. It doesn't work well if there's bone or air, but it's great for soft tissue structures like the bladder, the kidneys, the liver, the heart, and of course the reproductive tract. And we can use it on tendons and ligaments too. But we're looking here at an ovary. So here's an ovary. Trans just means transverse. So it just refers to the fact that we're seeing a cross section. And when you think about remember how I said a ultrasound is kind of like a flashlight. So think of a flashlight, but the beam of light is like a credit card. You know, it's just this very thin. And so when if we were to take this flashlight and look at an ovary, you have to picture what it would look like as the beam traveled through the ovary, right? It's going to look like a perfect little circle. It's not 3-dimensional, it's 2-dimensional. And so this is shining that ultrasound through an ovary, and we see these little little structures. Anything black means liquid. The more dense the tissue, the more white it will look. So if it's a little dense, it'll be gray. And if it's not dense at all, like liquid, it's going to look black. It doesn't mean the liquid is black. It just means it's liquid there. So there's some sort of a liquid in this structure here. The bladder will just look like a big black balloon. But of course, it's just pee. So what is that black? Well, that's probably the major follicle there. That's the big follicle, and these are probably some little follicles here, right? But that's a follicle you're seeing. She's probably, maybe she's not in heat yet, but she's going to be in heat. She's, that's going to become a much bigger follicle, maybe. Okay. I used to be a cow vet, and so I spent every day ultrasounding cows. And if a cow is pregnant, then that's great. If she was not pregnant, I would check her ovaries to see if we could figure out is there a reason why she's not pregnant. So this would be a cow ovary. And so again, what do you think? This is all the ovary right here. So I'm just going to outline the ovary for you. All right, so this is the ovary. Sorry, I'm not doing a very good job here. All right, so this is her right or left ovary, I don't know. So then what is this big black thing and these little black things? Oh, I wrote horse. Okay, well, I don't know. Maybe it's a horse. That's fine. But I wrote not. I should have said note. A little E there. Okay. Note that follicle is getting close to ovulating. And these are probably, again, other little follicles. And if we could see her ovary, that's what we would see, right? There's this big old, looks like a blister. It's kind of transparent. That thing's making estrogen, and there's a single ovum in there. Now this I know is a cow. All right. So now, again, here, this whole thing is the ovary. This is all ovary, 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 ovary. Okay, oops. So what do you think these things are that we're looking at? And this would be maybe a week after she was in heat. Well, these are, again, there's that main follicle. There's a new follicle developing, but this was the follicle from last week. It's now a corpus luteum. And this is what the corpus luteum would look like. So again, this is all part of this is all one ovary here. And then this part here is that corpus luteum that's making what? What does it make? Progesterone. And why does it make progesterone? In case the female gets pregnant, that progesterone will maintain the pregnancy. And this is probably another little follicle that ovulated, and maybe there's some other follicles developing. Okay. Okay. Now here's a cow where the owner says she's been in heat for a month. Maybe not a month, but this cow's been in heat way longer than he or she expects. So he knows there's something wrong with this cow. And we ultrasound her and we find, again, this is all her ovary. Trying to give you her ovary here. So this is all her ovary, and she's got these giant things, right? So it's a follicle, but this is an abnormal follicle. We call it a follicular cyst. It's just this huge follicle. It's never going to ovulate. And what's it making? Estrogen. And what hormone is responsible for the behavioral signs of being in heat? Estrogen. And when we say in heat, we mean sexually receptive. So this cow is very sexually receptive. Vinny was very sexually receptive to other male dogs, all because of estrogen. And that's what this ovary would look like if you could see it. This is that gigantic cyst right here, right? It's this huge follicle that's not normal. Um, and there's different ways of treating it that you'll learn about in pharmacology in a few weeks. Okay, that's the end of part 2. If you would like, you can now check your answers in the quiz thingy, and then I will see you in part 3.